Now we're going to look at another example that helps you differentiate from first principles. But before you actually watch the video, try to do this example yourself first. So what you'll find in mathematics is the more problems you do, the better you'll become at it. And so long as you don't do questions and problems yourself, you won't actually get better at it. So pause the video now and then watch it again after you've attempted it and you've hopefully be able to do it yourself. Okay, great. So now hopefully you've paused the video and you've attempted the question. If you haven't been able to do it, it doesn't matter. Just attempting a question will basically help you understand it in a whole new level. All right, so let's have a look at this question. We want to differentiate this function from first principles. But to do that, the first thing you do is think about your formula. What was our formula? Our formula was fx is equal to limit of fx plus h minus fx over x plus h minus x, which was basically h. Okay, so h goes to 0. Perfect, so that's your formula. So in order for us to be able to differentiate this from first principles, we need to be able to use these functions. So the first thing you say is, okay, I already know what fx is. It's given to me. So fx is equal to 2x squared minus 4x plus 2. What I need to now figure out is what is f of x plus h. Again, we said this before. This fx function is telling you that any input you give to your function is going to take that input, multiply it by 2, square it, minus it, blah, blah. So if I gave this again an orange or an apple, all it would do is it would take the apple, it would multiply it by 2, and then do this to it. Okay? So same with x plus h. It doesn't actually care that there's an addition there or anything like that. It's going to look at this as a whole. Okay? So it's going to put this, think about it as a whole. Okay, so that's a whole. It's going to square it, then minus, again your whole, and then add a 2. So in this whole, we're going to put x plus h. Okay, so your f of x plus h function in reality is 2 times x plus h squared. Remember that this whole thing is going to be squared and this whole thing needs to be multiplied by 2. That's why we have a bracket. Minus 4. Again, put x plus h in bracket and then add 2. Okay. Now it's probably better practice to try to simplify and expand this as much as possible now. Okay, so x plus h squared, again, that is going to be in the format a plus b squared. And we know that that formula corresponds to, if I want to expand that using this formula, it's going to be a squared plus 2ab plus b squared. And therefore, here I'm going to have 2 times x squared plus 2x h plus h squared minus 4x minus 4h plus 2. Okay, and then you can bring this out, 2x squared plus 2xh plus h squared minus 4x minus 4h plus 2. And just now, so that's your f of x plus h expanded. Okay, so now what you want to do is you want to subtract these two from each other. Put it in this formula and try to subtract them. So f dash of x, when limit of h goes to 0, we will have f of x plus h, which is this. So 2x squared plus 2xh plus h squared minus 4x minus 4h plus 2 minus your fx. And what's your fx is this. So, so remember that because it's minus that, so you'll have minus 2x squared minus 4x plus 2. And then when you subtract that, you need to multiply these minuses by each of these. Therefore, you will have minus 2x squared minus times minus is positive, and minus times plus is negative. Okay, so you will have minus 2x squared plus 4x minus 2 here over h. Okay, now try to simplify this as much as possible. So we cancel terms that we can. So 2x squared cancels that with minus 2x squared. Minus 4x cancels that with 4x. 2 cancels that with 2, with minus 2. And so what we have now is f dash of x is equal to limit h goes to 0. Then you have 2xh plus h squared minus 4h over h. And again, because this is a limit, if I just substitute this h now, I'm going to get 0 over 0, which is undefined. So what I need to do is I need to simplify this as much as possible first. So to simplify that, what I can do is I can factorize from an h, because h is common between all of these terms. So I factorize from an h, so that becomes 2x plus h minus 4 over h. Now this h can cancel out with that h, and so I will have limit h goes to 0, 2x plus h minus 4. And now that I've simplified this as much as I can now substitute this h is equal to 0 into here. And that gives me the limit. So that is going to be 2x minus 4. Okay, so this is telling you that the gradient function is 2x minus 4. So if this is my function, fx is equal to 2x minus 4x plus 2, if I'm trying to find the gradient of this function at any point, the gradient is going to follow this path. So if I want to find what the gradient of this function is at point 1, all I need to do is I need to substitute point 1 in this formula. So it's 2 times 1 minus 4, okay, which is minus 2, and so on. So that's what you do when you're trying to solve a question from first principles.